The following theorem justifies the use of the term closed when we define the concept closed sphere. The theorem states that in any metric space, XD, each closed sphere is a closed set. We have proved a similar theorem in the case of open spheres. We had proved that every open sphere is an open set. Here we are claiming that every closed sphere is a closed set. For the proof, let us consider a closed sphere, say SR of X naught. To prove that this closed sphere SR of X naught is a closed set, it is enough to show that its complement is open. That is, it is enough to show that SR of X naught, this closed sphere's complement, that is set X minus SR of X naught, is open. If we consider the case when this complement SR of X naught dash is empty, which is a trivial case, then we know that it will be open, as empty set is always open. Now let us assume that this complement SR of X naught dash is non-empty. And let us choose an arbitrary point, say X, from this complement. We know that the closed sphere SR of X naught is defined as the collection of all X for which D of X naught is less than or equal to R. So its complement can be expressed as the collection of all X which does not satisfy this inequality. So we can write, for every X element of this complement, D of X naught will be strictly greater than R. As we have taken small x from this complement, we can say that D of X naught is greater than R for this particular X. Hence, we can see that R1, which can be labeled as the real number D of X naught minus R, this real number will be strictly greater than 0. That is, R1 defined like this will be a positive real number. Now let us consider an open sphere SR1 of X centered at X and with radius R1. Then we can prove that this open sphere SR1 of X will be contained in the set SR of X naught dash. That is, we are claiming that an open sphere centered at X will be contained in the set complement of SR of X naught dash. To prove this, let us consider some point, say y element of SR1 of X, the open sphere. Then we can see that the distance between these 2 points d of xy will be less than r1. Since we are considering an open sphere, the inequality will be strict. This will imply that d of x naught x, which is in fact less than or equal to d of x naught y plus d of yx using triangle inequality of metric, we have d of yx naught is greater than or equal to d of x naught minus d of yx by rearranging the terms of the above inequality. And we know that this is strictly greater than d of x naught minus r1. Since d of yx or d of xy, that is strictly less than r1, we will be getting this strict inequality. This implies that d of yx naught is greater than d of x naught minus, we can replace r1 with the quantity d of x naught minus r, so that we get d of yx naught strictly greater than r. This implies that y belongs to the complement of the closed sphere SR of x naught, that is y element of SR of x naught dash. So we have proved the claim, and this shows that for every point of the set SR of x naught dash, there is an open sphere centered at that point contained in SR of x naught dash, which implies that this set SR of x naught dash is an open set as required.